We're going to go over section 1 and 2 on electricity today. All right, first, electricity begins at the what kind of level? It's the atomic level, where protons and electrons have electric charges. What carries a positive charge would be a proton. Electrons carry a negative charge. Ions form when atoms lose or gain electrons and become positively or negatively charged. Electrons can move from object to object. Static charge is when you're the building up of those electric charges inside of an object. And then a flow of charge can be used by ions moving in a solution. All objects exert an electric field on each other. That field can be attractive, meaning it goes together, or repulsive, meaning it goes apart. Like charges repel, unlike charges attract, so opposites attract is how I remember that one. Electric charges exert a force on each other at a distance through an electric field, which exists around every electric charge. This is a material that does not allow electrons to move easily. Those are insulators. So the opposite of that would be the material that does allow those electrons to move easily, and that is a conductor. Metals are the best conductors. Then the rapid movement of excess charge from one place to another is called the electric discharge. Lightning is an example of an electric discharge. And finally, for section 1 is grounding. It provides a pathway to drain the excess charge into the earth. Lightning rods, a lot of times tall buildings will have lightning rods at the top, so that way the electricity goes through those into the ground instead of going into the building. Now on section 2, we're talking about electric current. Electric current is the flow of charge through a conductor. In solids, the flowing charges are electrons. In liquids, they are positive or negative ions. What do we call a closed conducting loop through which electric currents continuously flow? That's called a circuit. Current flow can do work in an electric device. Flow carries electrical energy through a wire. Voltage. This is the measure of how much electric energy an electron in a circuit can gain from a battery. And electrons move in a circuit and have millions and millions of collisions, or the bumping into each other. The voltage of a battery depends on the amount and type of chemicals used inside those batteries. So the batteries use chemical reactions, and then those chemical reactions working in there together is what allows us to then draw that energy out of that battery. When the battery is dead, or when the battery dies, the original chemicals are all used up, and so those chemical reactions can no longer take place. Resistance, that is the measure of how difficult it is for electrons to flow through a material. Insulators have a much higher resistance than conductors. The amount of electric energy that is converted into thermal energy increases as the resistance of the wire increases. And the length and thickness of a wire affect electron flow. That's it for sections 1 and 2 on electricity.